See, every time. It's not even special anymore. Every time I can get it. So welcome to another Get Energized. Today's going to be really fun. It's a bit different. So we've been doing demos, right? In the beginning of the year is what's come up here. But we have some requests for guests again. So we have a wonderful guest who will be joining us shortly. We'll talk about that. Most importantly, I'm pretty much rearing to go. I got a lot of energy today. Dan, what am I drinking? What do you think is fueling this wonderful?
You're drinking soda.
Nah, I tricked you because I showed you soda earlier that I was drinking here. No. So what we have is Rainbow Mountain Blend Boss Coffee, and that's what's going to fuel me through this fantastic demo. Okay, so I knew I could trick you there, which was perfect.
Yeah, you got me.
I got you. I'm excited. I think this is going to be pretty cool.
Yeah, this is going to be great. I mean, we're excited to welcome Eduardo, who's a senior AI solutions engineer at Intel. Yep. Before Intel, he was a rock star geophysicist, so many people know him in the energy industry, looking at different types of subsurface stuff. Now he focuses on helping AI developers build impactful technology with Intel software and hardware. Now he's going to talk about the large language models and the compute optimized AI. So we're hoping for a lot of people to ask a lot of questions today. You have somebody who's an expert in the room. Yep. Please.
This will be fun. And to point out, so why Intel? Why do we have Intel going on here? A lot of the clouds powered using Intel for a lot of chips, a lot of workloads, and particularly in the energy industry, which is a very mature group of companies in most cases, a lot of Intel usage here. And so a lot of optimizing and workloads, and this kind of came up as a conversation point. So I will pitch that, is it asleep? Well, there's my beautiful Intel machine I was talking about building the other day, but I'm chilling just to get him excited.
Show it again.
I know, it's so pretty. It's only partially on, but that's EVA Unit 1. It's very nerdy. It's a very nerdy one. But without further ado, we've set the tone for our wonderful guest here. Eduardo, welcome.
What's up, guys? How's it going? Thank you guys for having me on.
We're excited.
It's really funny, watching the banter between you guys, having been just recently just kind of sitting with you guys, and then you guys kickstarting with so much energy.
Oh, we're very professional.
You guys. It's great. It's phenomenal. Thank you for showing off the Intel machine back there.
Well, it's the least I could do. No, we're very excited.
I appreciate it. And by the way, just so everybody knows, I wasn't in on the headband thing, so
it's okay.
Next time.
Next time. By the way, you have to get the wristbands too.
Oh my God.
We're all the way.
You're very, very coordinated, very serious stuff here. Yeah.
No. Thank you guys for having me on. And if you guys don't mind, I'll just go ahead and jump into it. And I do want to start off by saying that, after coming to tech from the energy industry, I always love the opportunities to talk about energy tech because it's something that's very close and dear to me, having started my career in that space. But let's go ahead and hit the ground running. And yes, I am going to be. Go ahead. Sorry. Yeah. Go ahead.
Can I pull up your screen?
Okay.
Yeah. Let's do that. Here we go.
All right, cool. So we'll go ahead and just address the elephant in the room, and that's ChatGPT and large language models. And the reason I wanted to just kind of touch on this in this particular talk and kind of build a theme around it is, everybody knows what ChatGPT is today. I think everybody has played with it to some degree at this point, and it's probably the most prolific AI machine algorithm or tool that's been introduced into society. It's created a lot of concerns for some people about their jobs, but I think in many ways it's just opened up a whole new a wide gamut of opportunities for this type of technology. But realistically, when we start looking at things like utilizing these kinds of technologies in oil and gas to make business critical decisions and in energy in general, being a very data guarded industry, I find that's going to be so difficult for us to use this because realistically, ChatGPT is not something, they don't have access to your data, and they're not going to have access to your data. No subsequent version, no successor to ChatGPT or ChatGPT-like models are going to have access to it. So it creates this issue where we're going to have a lack of specificity and granularity in using these kinds of tools for business critical decisions. So as a fun little kind of intro, I went ahead and pulled the OpenAI API down. And I asked a ChatGPT-like model to design a completion plan for me in Midland County, Texas, and to give me estimates of fluids, well spacing. I want to get something valuable out of it. I want to be able to plan my next frac with it. And when I look at the outputs, so I'm not going to run this live because it's the fear of always something going wrong with a live demo. Right? So,
you're good.
But when we look at the output, it's like, oh man, like if I didn't know anything about the industry, I've never worked in the space, I'd look at it and be like, wow, this thing knows what it's talking about. But when I dig into the actual, to the details, I can zoom in a little bit too, by the way, to help,
yeah, good call.
The audience can look at it. When I look at the output, I start to see, some inconsistencies, lack of specificity. It's, every single sentence starts with, so-and-so should be done to maximize production and minimize costs. It seems like it was pulled out of a brochure. And I think that's because that's really the level of granularity that a lot of these algorithms have when looking at domain-specific information. So in short, here's a meme for you guys. If you design your next frac with ChatGPT, you're fine. Don't be doing that stuff, guys. You don't want to. You don't want to be risking your career that way. So that's essentially where I'll transition to this idea of domain adaptive search engines. And this is a term that I kind of came up with, a nice acronym that I could refer to when I'm talking about it, so I don't have to repeatedly say domain adaptive search engines. And the idea behind this is, chatbots in general and ChatGPT, at the end of the day, they're kind of just well-managed search engines, based on neural networks. And if you know anything about neural networks, they're terrible extrapolators and they're typically great interpolators, right? And the problem is that in the interpolation phase, because there's no granularity of business critical data, when it tries to fill in those gaps, the best you can hope for is some kind of high level abstracted answer. You're never going to get deep into, the interpolation will never get deep enough for you to get the real value. And when we talk about extrapolation, you risk, you put yourself at risk of just garbage in, garbage out scenarios and, extrapolating to kind of nonsense, the kind of nonsense we've seen, some people come up with when using ChatGPT for other applications.
That's all over Twitter. Yeah, if you want to find stuff, people.
Yeah. I won't go into the recent one that came out from Google. So, so here, this is where domain adaptive search engines come into the picture. And the idea behind this is it's just a way to refer to this idea of taking a large language model or a multimodal foundational model and domain adapting it to transfer learning using your internal proprietary data and a mix between that and open source data, so that you can actually build a tool that can drive business value and answer business critical questions and derive insights across different domains and different modalities potentially. And essentially what you end up with is kind of like a co-pilot or an oracle for your day-to-day business activity. And I have a little bit of a diagram here to show like what at a very, very high level this would look like. The key thing that's missing here is the data engine that makes all of this possible. And that's I'll touch on that briefly in the next section. But the idea is, you take your data sources, you have to sit there and, very, very diligent about labeling and specifying, what that data means to you from a business critical, operational perspective. And once you have that ready, you get that into a format that is contextual for your model through tokenization and embedding. Then you take that foundational model and essentially, foundational model is essentially just a model that's been pre-trained and has pre-trained weights and it's designed to achieve a particular task. But what you're doing at that point is just giving it your data, perturbing it ever so slightly so that it now has contextual information about your data, your business use cases, and et cetera. So what you end up with and what the ideal situation would be is, you no longer have these kind of 10,000 foot view kind of answers coming out of your models. You have something way, way more in depth that you can actually, you can take actions on. So an example here of an interaction with a DACE would be like, give me the, what porosity profile can I expect at a depth of 12,745 feet in our latest lease in Lea County, New Mexico. And what I'm expecting from it is to know what my latest leases are in Lea County, have access to all the background models that I have inside of my database so that I can derive these kinds of insights. And in short, the concept of the DACE is just to highlight a particular concern that a lot of people have with the introduction of large, mega large models. And it's that I don't think in the near term future, we're going to have this all knowing AGI that takes all of our jobs. I think the likelihood is that we'll have many of these DACEs or domain adapted search engines that will be, on a domain specific or organization specific level, helping us with our day-to-day activities. Yeah.
Cool.
Yeah. And I'm going to have to skip through a couple of sections here in the interest of time, but we can come back to them. You can think that, or you should start really thinking about it. Think about all the challenges this presents. If you're going to have, if I'm sitting here today and I need to perform my daily functions as an engineer, as a business professional, whatever function I perform within my energy organization, there's a chance that the freshness of data is a factor that's changing every single day. I'm getting new data every single day. So what does that mean? That probably means I'm going to have to continuously put my model and have very key model observability like infrastructure in place, so that I know whether my model's answering the right questions for my employees and my team members.
So related to that, just to interrupt, so in terms of the model and what you're getting to here, someone asked how do you pick the software package that relates to this here?
Okay, so I'm going to assume you're referring to the package that you use for training the model. And I think that, just a high level suggestion is, it never hurts to start with the most popular ones. So you have PyTorch and TensorFlow as like kind of the incumbents and the most popular deep learning frameworks. So starting with those is ideal, but I'll touch a little bit on actually pivoting to selecting I guess the hardware optimized versions or plugins to those popular frameworks, so that you get the most out of the underlying hardware. Yeah. Cool. So it's a great question. I'll touch on it in a little bit. So going back to this idea of how do you support this domain adaptive search engine infrastructure? You're going to have data coming in every single day. Your model's going to need to be updated every single day. Then you're going to have your entire organization submitting inference requests to this model and essentially expecting a valuable response. And that takes a lot of compute. So I did want to touch a little bit on this concept of making deep learning more accessible and cost effective, so that this technology can truly be democratized. Because if not, it just becomes more of the same, where we just have the very large deep pocket companies all having access to this technology, right? So
you don't want something that's not cost effective for your company in general.
Of course, especially if it's going to be something that's like so business critical. If you depend on it that much, right, it needs to be something that can scale well with your business, right? And I think there's a myth, and I bring this from my previous experiences and in discussions in the community every day, and it's that the best hardware for all AI ML workloads is the GPU. And the truth is really that the best hardware for AI ML workloads depends on the workload that you're working on. So if you look at traditional machine learning workloads and inference, the CPU is king there because of its high availability and low cost. But when you look at deep learning, historically, the GPU has been the ideal place to go for deep learning training because of its functionality and its ability to perform efficient matrix multiplication and matrix operations, which is ideal for neural network training. And where this brings me to is kind of trying to open the minds up of the developer community and thinking more about heterogeneous compute and thinking more about the different options that you have, and being more of a compute aware developer. And when we look at the recent advances, particularly in Intel's 4th generation Xeon Sapphire Rapids chips that we released last month, it comes with instruction set architectures that are dedicated for accelerating deep learning workloads. So although we're not talking about completely displacing incumbent accelerators, it makes it so that now the CPU is a sensible choice for many organizations with specific workloads like fine-tuning and transfer learning, like what I've discussed in the DACE and the domain adaptive search engine.
And a lot of people would never have thought of that historically. I mean, even just very recently, they would still be thinking it's GPU or bust, basically, once you have this. So
what's the training time difference between
them? So I have a demo later, but I will send you a link, Dan, so that you can look at the official benchmarks across, comparing to incumbent accelerators with 4th generation Xeon. They don't have that particular demo here today. Yeah.
It's okay. I realize I could send the PyTorch documentation for Intel right now. Right here.
So and touching briefly on this concept of coming from energy to the hardware tech world. And I think like in my previous roles, touching on this, like being a hardware aware or compute aware AI developer. Historically, I was, I jump on the AWS cloud, look at the core counts, look at the price. Oh, this makes sense. Let's go with that, right? And run my workload on that. And I never thought to think that there were specific toolings that not only just comes, and this is true about all hardware providers and silicon providers, there's tooling that the experts at those companies have put together so that you can get the most out of that technology. And I think as developers, sometimes we just look at the frameworks and run with them. And that's where I'm touching back on your question or the audience's question, Dan, is there are specific packages, like for example, Intel's extension for PyTorch or Intel's extension for TensorFlow, and that are part of the OneAPI AI Analytics Toolkit. And that toolkit exists basically so that Intel can always provide you with the latest optimizations to kind of tag onto that framework. So what we'll look at today in the demo is actually using Intel's extension for PyTorch in tandem with the main PyTorch library to provide additional acceleration.
Very cool. So if you want to follow along,
cool, I mean, I imagine people run into that all the time where they're not optimizing their workflow, and being able to have an option to optimize the workflow would be very helpful.
Right. And I put this together here, like just kind of like my MO previously compared to today. And before, again, like just picking the hardware, looking at memory and core count, and then starting to write code. But today I'm more about, validating that I have the right amount of cores, memory, networking speed, then looking at the right optimized package, then making sure I include the correct lines of code and parameters in my code to activate the optimizations. And a really important part is after you hit run, go look at your core counts, go look at your utilization, go look at your machine topology,
actually
make sure that you're actually using what you think you're using, because sometimes you're not. And it's going to be very frustrating.
More often than not, if we admit it, right? Yeah.
Right. So here's another meme for you guys. So randomly selecting instances on the cloud versus being a compute-aware AI developer.
There we go.
So that's my if you take nothing away from this discussion today, be a compute-aware AI developer. And this actually brings us all the way to the demo. And I have a ton of content here. What I'll probably do, Dan, I don't know if you guys have notes in the recordings of this, and you could potentially add.
We can put notes in.
Yeah. Some, when I have this published and ready to go in a repo or something, I'll go ahead and ask Dan to put it or Lee to put it in the notes so that you guys can take a look at it. But yeah, definitely give a couple of weeks for that to show up there. So let's talk a little bit about, let's play with the massive Sapphire Rapids node that we're on right now. Let's talk a little bit about tips and tricks about understanding machine topology and the Intel's extension for PyTorch. So let's go ahead and jump over to our command line. So if you've never played around with this, if you use the LSCP command on an Linux machine, you're basically going to get a printout of your machine topology, the description of basically what you're running on. And here's just a very quick way to interpret this. So here you can see the model name of the machine. If it has, if it's 84, if it has this 4 here, it means it's 4th generation Xeon. So that would mean that you're running on Sapphire Rapids. The cool thing about Sapphire Rapids, and I didn't touch on this too explicitly earlier, is the fact that, let me just run this, LSCPU, AMX. So is that you have the advanced matrix extensions and support for bfloat 16 floating point accuracy. And what that means essentially is that when it comes to training deep learning models, you can vary the precision of the weights in your model, and having the precision in that step basically makes it so that the matrix operations are easier. You think about like when you're doing multiplication by hand in school. I don't think people do that these days. Right? The more decimal places, the more like different kind of carrying the numbers, and you had to do right tracking the decimal point. That's true of the machine. It just does it much faster. So when you think about having to deal with just less numbers after the decimal, that speaks to the optimizations that you get there. So that's something that's enabled here. But again, just looking quickly at the machine topology, this machine has a total of 224 threads. It has 54 cores per socket. 2 sockets, and 2 threads per core. And if you don't know about threading, essentially for every core, you're going to have a virtual and physical core.
Yeah, this is a big boy.
Yeah, it's a big bare metal machine. Yeah, yeah. And I do have the link that I shared with Lee. If you guys want to get access to a similar machine like this, they're on preview on AWS. It's going to be the R7IZ series. So you can get VMs, but you can also get bare metal machines on there, and you just got to request access, basically. Okay, so let's go ahead and jump through, skip some of this. I'll come back to it in a minute and talk about the actual demo for the application we're looking at today. So we're looking at an AI-powered customer care bot, care chatbot, and this is based on an Intel AI reference kit. I have that link with Lee as well. And basically, these are like blueprint end-to-end source code that helps you implement Intel's accelerations from at the software level on Intel hardware. And basically bakes it into a use case. So in this case, we're looking at a customer care bot, a care chatbot. If you look here, this is I'm importing all of my libraries, but here's the key one: Intel's extension for PyTorch being imported as IPEX, and you'll see how how easy this is in a minute. And realistically, let me just scroll down. I have a ton of code here that we don't need to go through. But my training function, as you know, if you built PyTorch models before, you have to specify and build your own training function. There's 2 lines of code here that I'll highlight that essentially you need to have to activate bflow16 and to activate AutoMix precision. So this is 1 line of code here: ipex.optimize, feed it your model, feed it your optimizer, and you specify the D type. So in this case, it's bflow16. That's going to tell IPEX that, hey, it's okay to use half-point precision. Okay. And then when I actually do run my training loop, I want to make sure that I wrap it around this command here, torch.cpu.amp autocast. And AMP stands for AutoMix precision. So it's basically letting it know that in the process of training this model, it's okay to mix the precisions between FP32 and bflow16. And that's it. Those are the only 2 lines of code you need to add. Everything else in your code can stay the same. And you'll see what kind of the uplift is in that in a minute. I have some basic number here. I won't go through, like I said, I won't go through all the code. This is just like some hyperparameters and tokenizing my data set. By the way, if you're curious, this data set is the airline travel info systems. It's a very famous data set for intent. Intent prediction. So intent prediction is basically like if I ask I want a flight from, or what flights do you have available from Orlando this afternoon? The intent that the machine understands extracts is this person is looking for flights, out of Orlando, right? And then it can parse a database for that information.
And you'll be able to, can you send us some of this at the end, and we'll put this into the VOD and notes for everyone?
Yeah, of course. Yeah, let's for sure talk about that. Yeah. So here I've written 2 different examples, bflow16 with AMX. Again, that's what's enabling the AutoMix precision. And then just Intel's extension for PyTorch with floating point 32. So it doesn't have access. You can see here, I've given it FP32 here and told the AMX false. So I'm not using that functionality. When we look at the model performance summary, and this is a quick disclaimer here that this is clearly not like a standard industry benchmark that I'm showing here, but it's just based on my code, and it can vary depending on how you're configuring your machines and how you build your code. But essentially, looking at the training time, comparing FP32 to bflow16 with AMX, we do see a 2.29x increase in performance in terms of training time. Okay, so if you're thinking about just adding 2 lines of code and getting
huge savings.
Right, exactly. And it's going to vary with your data set. It's going to vary on your use case, right?
Naturally.
This particular one, this is what we're looking at. And then if we're looking at the on inference time, if we compare FP32 to bflow16 with AMX, we're getting about 3.67 times uplift in comparison. So again, just adding 2 lines of code to get these kinds of things. And that's where I think there's a lot of power. It's like people don't think that they can by working on the right hardware, but making just a few decisions at the software level, you can have such an impact on your solution.
That's why architecture matters so much, and understanding this here. This is big takeaways. Yeah,
for sure. And then last point I'll touch on before wrapping up on mind is understanding that there are, like when I talk about specifying and being compute aware, there are certain, for example, environment variables like OpenMP environment variables that you can set to customize what your machine's going to have access to for a particular workload. So in this case, I'm using OMP num threads and specifying 16 threads. My workload is not so expensive that it's going to need those 200 and the 200 some cores. If I do that, I'm actually going to bottleneck at the memory in memory, because it's having to move memory around through so many threads. I'm going to bottleneck there, and that's not going to be efficient for me. So what I've done is actually taken this massive machine and brought it down to just 16 threads, and I'm getting that much just out of that. And 16 threads is closer to what you can expect from like a VM, rather than like 200 or so threads in this machine. So like if I run this right now, for example, I'm just going to run it down here in a little block I have designated for this, and we'll take a look at what that does. So I'm going to run this real quick, and I'll go over to my command line. And I'm just going to use the top functionality. I'll see immediately that I'm verifying right here. Okay, I have 1600% CPU utilization. I'll write down a little bit there, but it's probably part of it's starting something up. The idea being that when I move over to actually looking at what's being used in my machine, I can start to see I can use this tooling to be more compute aware of what's going on. I have to zoom out so much because it's so many threads, right? But essentially, if you didn't have that many threads, you don't have to worry about this scenario. Okay. But yeah, so that's basically it. I mean, in summary for this demo, I wanted to make sure that developers out there aren't making the same mistakes I made before coming to the role that I'm in today. Understanding that if we're going to be ambitious and deploy things in organizations, particularly in energy with our data guarded nature, that are something like a DACE, domain specific search engines, we're going to need some very very flexible, affordable compute to make that model work for many organizations. And making sure that your developers are being compute aware is just going to make that experience all the better. Especially at your bottom line, right? Looking at how much you're spending on supporting this kind of infrastructure.
No, it's very cool, honestly. And again, thanks for doing this, because it's not the kind of thing most would think of. I myself was really pretty interested in that, and appreciate seeing it. And the fact that you knock it down to adding a library and 2 lines of code makes it pretty appealing, right? So that's pretty cool.
Right.
It makes a huge difference. You can see it right there.
Well, this is great. Eduardo, I realized one thing I didn't put a link in is the Intel chatbot reference kit. I didn't mention that, so let me. Do you want to say what that is quickly?
Yeah, so that is there's various reference kits. So there's, like, for example, one for demand prediction. There's one for QA/QC and visual inspection, and there's a ton of them that we've released. And the one that I used today is the chatbot one. So it's essentially is like it's a source code that builds to a chatbot application that already has like codified all of these optimizations, so you can kind of just hit the ground running and adapt it to your use case. Yeah.
Awesome. Thank you. So we've got that out, Eduardo. It's awesome having you here. Thank you very much for this.
Appreciate it, guys.
I appreciate it. Thank you so much.
Yeah, the memes are appreciated as well, of course. So
glad you guys enjoyed those. Yeah.
Yeah. All right. Thank you.
All right. Take care, guys. Thank you. Goodbye.
That's all we got for today here. Sort of plans for now, but we'll probably have some more guests coming up as well. Some more demos. The hoop is next to Dan if he wants to try to take a shot here. I mean,
I made it last time.
I know. So is it 2 in a row? Probably not. Yeah. See, you can't. 2 in a row is asking way too much. Asking way too much. Anyways, that's the plans for now. We always love having you here. We will be adding notes to the VOD for this session. It'll happen. We'll get that done.
Yep.
We're not set in stone again. We tend to have plans where we're going, but reach out, give feedback if you like these sessions. If you have other topics, let us know. And yeah, there you go. So we will see you 2 weeks from now again.
2 weeks.
And for that, by all means, let us know if you want to see some other topics. But we have a blast doing this. We just do this for fun, and hopefully you're enjoying something. So take care.
Take care, everyone.
Everyone, see ya. And again, I will say, next time the basket happens, I'm calling it. Okay.
I got it. I got it the first time.
I know. So it's gonna be like an every other this time. All right. Take care, everybody.
Bye.